Having understood to draw the RE model of a BJT, now let us use an RE model in the AC equivalent circuit of a CE amplifier. Students, in your syllabus, you have to use the RE model of a transistor to derive expressions for AV, Zi and Z0. I hope you know what is AV. AV is the voltage gain, Zi is the input impedance and Z0 is the output impedance. Another word of explanation is, see, given an amplifier, students, you should know 4 important things about it. So, 4 important characteristics about it. So, which are the 4? Your voltage gain, the input impedance, the output impedance and the current gain. Okay, it is like the biodata of a student. So, where is he from, what is his qualification, which school he has studied. Likewise, even for an amplifier, given an amplifier, you should be knowing 4 important quantities. Okay, so that's what we are going to learn in this part. So, in the previous video, we have learned how to draw the AC equivalent circuit of the CE amplifier. Isn't it simple, student? So, you just have the BJT, the emitter is connected to AC ground. If you remember, I also told you it is called as a CE amplifier because the emitter is at AC ground, not DC ground, please note. And you are having R1 parallel R2 between base and emitter, and you are having RC parallel RL between collector and emitter. So, if you don't have RL, it is only going to be RC when RL is not there. That means RL is equal to infinity. Okay. So, I hope you have recalled this AC equivalent circuit. All that we have to do here is, wherever your BJT is there, since we have understood and analyzed a BJT in terms of the RE model of a transistor, we just have to replace the BJT with this. Okay. So, it will take some time for you to understand and draw it, students. So, practice it once or twice. Draw the CE amplifier, draw the AC equivalent circuit, draw the RE model and then replace the BJT with RE model of a transistor. So, students, so look here what I have tried. I have tried to a little more explanatory for you. So, keep 3 dots like this: base, collector and emitter. So, between base and emitter, you are supposed to draw a RE dash. So, you see here between base and emitter, you have RE dash. Between base and collector, what is there? Between base and collector, what is there? You have a constant current source. So, between base and collector, you have a constant current source. So, these remains the same. So, you have Vs, you have R1 parallel R2 and you have RC parallel RL. So, what is this, students? This is the CE amplifier, the AC equivalent of a CE amplifier circuit with the BJT replaced by the RE model. So, to give you a further recall, what is RE dash? RE dash is the AC emitter resistance. Okay. Now, let us see how to determine the expression for voltage gain. So, students, it is very simple. It is hardly a matter of 2 steps. So, please note. So, we all know the definition for voltage gain, isn't it? So, it is a ratio of output voltage by ratio of output voltage to input voltage. Okay. Now, go back to this diagram. So, what is output voltage? Where are you measuring the output voltage? The output voltage is measured across RC parallel RL. How to measure voltage across a resistance? We use Ohm's law. So, what is the current that is flowing through this? So, you see, students, it is IC. IC is flowing through the through RC parallel RL. But students, watch. So, we know, no, according to KVL, the current, the terminal through which current is entering is considered positive. The terminal through which current is leaving is considered negative. But then what do you see here? Here current is leaving the positive terminal. So, what? So, it is opposite to that of the convention. So, please note here, according to Ohm's law, what is V0 equal to? V0 will be equal to IC into RC parallel RL, but with a minus sign. So, watch out here, students. So, what I have written here, V0 is equal to IC into RC parallel RL with a minus sign, because the assumed direction and the actual direction are opposite to each other. That's why this minus sign has entered into this expression. Now, what is V in? Go back to this. So, where is V in measured, student? V in is applied across R1 parallel R2, and this is in parallel with RE dash. Since we are more interested in the transistor, we would prefer to say that Vs is dropping across RE dash. So, what is the voltage drop across RE dash? If I know current through RE dash, I can determine what is the voltage drop across RE dash. So, V in will be equal to current through RE dash into RE dash. So, what is the current through RE dash? Current through RE dash, this is emitter, isn't it? So, emitter current is flowing through this. So, please see here that V in is equal to IE into RE dash. I hope you are familiar. I have written everything in lowercase. We have written everything in lowercase because we are talking of about AC, that is the AC equivalent circuit. Now, substitute these terms or these expressions into the voltage gain. So, what do you see here? You have minus IC into RC parallel RL, IE into RE dash. So, here students, you see that this IC and IE vanishes. So, in a BJT, we know that the collector current is very close to the emitter current, assuming these two are equal. So, IC and IE dash, IE are cancelled. So, the expression for voltage gain is minus RC parallel RL divided by RE dash. Now, what is the significance of this minus? Here, if you remember students, we know that if your input to the amplifier is like this, the output voltage obtained is like this. So, what do we call this as? This is called as phase inversion, isn't it? It is also said that a CE amplifier is an inverting amplifier. So, the minus sign here indicates that the output is out of phase with that of the input. Okay. So, what does this minus sign indicates? It indicates the output is out of phase with that of the input, or a 180 degrees phase difference is represented by a minus sign. I hope this is a very simple derivation. The question on this can be something like this: derive an expression for voltage gain using RE model. So, isn't that simple, students? So, here if RL is infinity or if RL is not there, the expression is simple. It is simply minus RC by RE dash in the absence of RL. I hope it is understandable.